Okay, so I want to look at just one more video about continuity, just to kind of make sure we're on the same page here, and looking at functions and kind of applying maybe what we learned in the last video, but the different types of discontinuities, whether they're removable or non-removable, and if they are non-removable, what kind is it? So it says determine the continuity of each function below. So I'm hoping that when we see this function, we clearly recognize that there's a problem with having x in the denominator, because at one instant, in this case x being 0, there's a break in the graph, right? We know that x cannot equal 0. But the thing is that there's nothing I can cancel. There's no factors to cancel. So the fact that there's a 0 in the bottom and like a 1 on top, that's telling me there's a vertical asymptote. And if there's a vertical asymptote, that particular graph, that's a non-removable discontinuity, right? And what kind is it? Oh, it's a vertical asymptote. So when it just asks to determine or kind of analyze and discuss our function, there's not a lot of rigor in terms of proving that it's discontinuous. Like, it doesn't ask me to prove the limit from the left doesn't equal the limit from the right, kind of thing. So one side's up, one side's down. So that's the discontinuity. It's non-removable. Let's go to this nice green here. So it's non-removable. And what kind of discontinuity is it? It's a vertical asymptote. Okay, so, and again, not asymptote. asymptote. There it is. Okay. You should recognize that just by looking at the function and being familiar with that particular function. Okay. Now, the next one, again, another problem in the denominator, right? X can't be 1 because there's another 0 in the denominator. So I know x cannot equal 1. But if you try to substitute that in and get 1 squared is 1 and minus 1 is 0, and 1 minus 1, which is 0, we get 0 over 0, which is characteristic of a whole. And a whole is removable. And another characteristic of a whole is that you could have factored this, right? X minus 1 times x plus 1, x minus 1, they cancel. And so I know there's a whole. And this function's going to really behave like x plus 1, which is linear. So if I were to draw that graph, up 1, slope of 1, it's just that when x was 1, there's a hole, and the graph continues. And I know the geographic spot of that hole is 1, 2, because when I put in 1 to the remaining part, what is it equivalent to? 1 plus 1 is 2. But again, going back and discussing the continuities here, or the discontinuities, it's a hole, right? It's removable, and right, a removable discontinuity only has one choice. It's a hole. Okay, part C, when you have piecewise functions, you sort of have to worry, in D as well, you have to worry that they line up, right? If one side comes to here and one side comes up to here, they're not lining up. That's a jump discontinuity, which is non-removable. So the way you check is just to put in the boundary point, which is 0, to both. So 0 in the upper hand of that function looks like it's getting close to 1. 0 on this one looks like it's getting close to 1. Or if you say, what's the limit as x approaches 0 from the right, of h of x, is equal to 1. And the limit as x approaches 0 from the left of, h of x, also equals 1. And it's defined, right? h of 0 is 1. So I know it's continuous. So you have two functions that this is parabolic, x squared plus 1. So when you're greater than 0, it would have been something like this. Now this is a linear function that just happens to start where that ended, fills in the hole, and goes something like that. So the two pieces line up. So it's continuous everywhere. For all real numbers, it's continuous. Now, another piecewise function down here in part D, same concept. Let's look at 0. So that's our transition point. The limit as x approaches 0 from the right of k of x, one that's bigger, is sine of 0. And sine of 0 is 0. The limit as x approaches 0 from the left of k of x, less than 0. So 0 minus 1 is negative 1. Well, clearly 0 does not equal negative 1. So these two pieces don't line up. There's going to be a jump discontinuity, and that jump is non-removable. Now, what does the graph look like? Well, if you were to sketch this out, the linear component, when you're less than or equal to 0, would start here at -1. And again, I'm doing if it's less than or equal to 0, looks something like that. And then a sine function starting at 0, open dot, and get your nice aesthetically pleasing sine wave. Okay, so again, just recognizing the different discontinuities and applying some of the vocabulary to those situations. Okay, so again, review these 2 videos and let me know if you do have any particular questions, and that's how we'll start class tomorrow.